Okay, hello students and welcome to today's lesson. We're going to be looking at working with algebraic terms. So today we should be able to simplify algebraic expressions by collecting like terms and cancelling. So we'll have a look at, first of all, this like term business. So terms containing the exactly the same pronumerals are called like terms. The order of the pronumerals can be different. So the pronumerals is just the letter. So if I'm saying 2AB and 3BA, I look at the letters, and if the letters are the same, or these pronumerals, they are like terms, because this can be rewritten as 3AB. Generally in maths, we put them in alphabetically ordered. Okay, now like terms can be added or subtracted by adding or subtracting the coefficients of the terms. So terms can be multiplied or divided whether they are like or unlike terms. So if I'm looking at this example here, 2AB plus 3AB, I can look at this because here are our coefficients, and I can simplify this by adding to make that 5AB, because the terms are like terms. They have exactly the same pronumerals or letters. Now when multiplying algebraic terms, multiply the coefficients together first and then simplify the products of any pronumerals that are the same by using index notation. For example, k times k equals k squared. Now when dividing algebraic terms, the division problem should be written as a fraction. Writing algebraic terms in expanded form can help identify the common factors. So let's have a look at our first example. If we want to simplify this, we can note, yes, we have A, and A. They are all exactly the same pronumerals, so they are indeed like terms. So I can add or subtract the coefficients. Now the coefficients are the numbers in front of the pronumeral. So I just say, well, 10 take 6 is 4, and 4 plus 5 is 9. So this is going to be 9A. Now let's have a look at this one. This is a little bit more complex. So what I'm going to do is try and highlight all the like terms. So let's look at this one here. I've got 6xy, so I'm looking for any other term which is like this one, and it is this one here. And I'm going to highlight the value in front of the coefficient as well. So 6xy and negative 2xy or yx are the same. Now let's have a look at any other values. Let's choose a different colour. Okay, negative 3y. Are there any other terms with just y in there? There is. Now you can see that that's got a y there, and that's a silent number 1 there. So you can think of that as a 1y. And there's no other x. So if I were to highlight x, we've got a negative x. There's nothing there that's like it. And a y squared, there's nothing like it. So what I'm going to do now is just rearrange this, I suppose we call it an algorithm or expression. So with all the like terms together. So let's do this. I'm going to go 6xy. And notice I've done my x as a curve rather than that, which is a times. So when I do algebra, I generally write my x's like the cursive x. Now I'm going to transport this negative 2xy over next to the 6xy. So this is what I mean by collecting the like term. So those two terms are together. It just makes us easier to do. So let's continue. Then we've got to take 3y and a plus 1y. And we coloured that in yellow. So you may like to get a highlighter out when you're doing this. And then let's just look at the other two terms. Take x and plus y squared. Well, there are no two terms that are like x or like y squared. So now that we have grouped our like terms, we can perform the operation. Now 6 take 2 is 4. We perform our operation by adding or minusing the coefficients. Now negative 3 plus 1 equals negative 2. So that's negative 2y. And then we have a take an x and then plus a y squared. And that is what we call simplified. Let's have a look at a few of these now. Now, what do? We multiply the coefficients together. So 7 fours are 28. And then we've got d times a or de times ab. In this case, I'm just going to add in each of the coefficients. So that will be my simplified expression there. Let's have a look at the next one. Let's multiply our coefficients together. So I've got a 5 times a negative 2. Well, 5 times 2 is 10, and 5 times negative 2 must be negative 10. Now I'm going to look at multiplying. So we're going to multiply, and we're going to have to just go through this in order. So I've got an x squared and an x here. Now x squared is x times x. If I'm multiplying it by x again, that's going to equal x to the power of 3. So that's the next term that I'm going to put in. Then I've got a y. There's no other letters with y in there. Then a k and then a w. Now I could just rewrite this in alphabetical order. So there's a 10k and then there's a x, y and z. So we go x to the power of 3, y, wxy. Oh, Mr. Beasley. So let's just put it in a wx to the power of 3, y. And that's simplified. Now, when we're doing a division, it's always easier to write your divisions as a fraction because you can just cancel out. Now, we're just going to have a look at our coefficients first. So 15 divided by 10. Well, we have to cancel out. And so 5 goes into 15 3 times, and 5 goes into 10 2 times. The next thing we can do is we'll say a divided by a is 1 and a divided by a is 1. So we now have 3b over 2. So remember, any number divided by itself is 1, and therefore we can just cancel that out. We can write this a couple of different ways, but we could, for example, say 3/2 of b as well. Okay, let's have a look at this one. We've got 8xy divided by 2wx. So we need to set this up as a fraction. 8xy over 2wx. Now I can just cancel out. Look, there's a letter and there's a letter. So that will cancel out already. X divided by x is 1. So remember, any number divided by itself is 1. I can cancel out the 8 and the 2 and simplify that. So 8 divided by 2 is 4, and 2 divided by 2 is 1. So I can just drop that 1 and not have anything there except for that w. Now I'm just going to rewrite this in its simplified form. And I'll just get you to copy my working there, please, and then go on to the mastery exercises for the lesson.